Okay, this is a bit of background, an introduction to standard deviation, which is on Engineering Mathematics HNC. This is basically learning outcome 2, investigating applications of statistical techniques to organise, present data by using appropriate computer software packages. Okay, so we're looking at standard deviation. This will then be going to use to look at normal distributions, standardised normal distributions, and working out associated probabilities. First of all, though, we need to get our heads around standard deviation. Okay. Right. So here I've got two sets of data. So here we've got people's age. See, going from 42 to 18. Here we've got people's shoe size. So the class I have are all male, all 18 or above. So we'd expect for this class the standard deviation of their age to be greater than the shoe size. That's what we're expecting. Okay? Because you can see these numbers here are more tightly dispersed than these numbers here. So that is what standard deviation is, really. It's a measurement of dispersion of data. Okay? And there's a formula for it we're going to use. So this is the formula. So it looks very complicated, but ain't really that hard. So first of all, symbols. Sigma here is standard deviation. Capital sigma is the sum of. X is your datum, so in our case it's one individual's age. X bar is the mean, N is the number of bits of data. So every individual bit of data, we take away the mean. Okay, so this result in this bracket could be positive or negative. One aspect I always think of standard deviation is this squared here. You've got a square here and then a square root. So really a difference can be negative or positive. So that kind of squaring and square root kind of cuts out that. And so you add these all together for each bit of data. Divide by how many bits of data there are, do the square root, you've got your standard deviation. Okay? So this will eventually tie in another video clip to the normal distribution. So a lot of things in life are normally distributed. In industry, you hear of something called Six Sigma. So Six Sigma means your data is grouped in this area that I'm showing here. Yeah? That's basically what Six Sigma is. So hopefully it's very unlikely to get outliers above or below what it is you're looking for, yeah? Okay, so we're now going to do a calculation using a spreadsheet. This is the best way to do these, okay? So not much faff, using a spreadsheet. So building up to this table you can see here. First of all, though, we'll do an elementary calculation on this spreadsheet. Right, so first of all, I need the mean. So I need to add all these datas up. So this equals the sum of this group of data, of the total. How many bits of data are there? Quite a cool little thing on this spreadsheet is I've highlighted data. You see down here, count, so it's 10. That's a good little tick there. So the mean is going to be equal to 251 divided by 10. Gives us 25.1. Okay, so we've got the mean. So I'm just going to highlight that. Right, this column then is going to be our x minus x bar. So remember that is that bit there, x minus x bar. So this equals the data, individual bit of data, minus my mean, 25.1. Spreadsheets do things dead fast. So there you go. Right, I now need to square that data. Okay, so just in that bracket there, I'm now going to square it. This column is equal to this squared. Okay? Okay, I now need to add sigma that column. So equals sum of these. Okay, so I've added them, and now I've got to divide by how many bits of data there are. That equals that, remember, 10. And then finally, the standard deviation. So standard deviation is going to be equal to bigger square roots of that. So equals SQRT. That. Okay, and that's your standard deviation. Now there is a shortcut in the spreadsheet. All I do is type in equals ST standard deviation. Highlight the data. You see, yeah, that's done in seconds. The standard deviation, as expected, is lower for the shoe size than the age. Okay, that's exactly what we expected. Okay, so that's basically how you do standard deviation on a spreadsheet that you're going to do in your assignment. One last thing, group data. Pretty much identical with group data. Okay, other than, so here, this example I've got ball bearings. Ball bearings go from 0 to 5 mil. So this is outside of the tolerance, by the way. And then the worst case is between 35 and 40 mil outside the tolerance. Here it's not 5th of October, it's because the spreadsheet doesn't recognise 10, 5 to 10, it thinks the 5th of October. So you probably work out, well, that's 10 to 15, that cell there, yeah? So I'm not 100% great on spreadsheets, but I'm sure you can figure that out, spend a bit of time. So anyway, we're interested in this mid-interval value. So the ball bearings then, 68 of them between outside tolerance of 0 and 5 micrometers. That should be micrometers, by the way, not millimeters. So one of them could be, 20 of them could be 4 micrometers outside. One of them could be 1 micrometer outside. So we don't know whether 0 or 5. So we pick the middle, which is 2.5. Second group, remember that's supposed to be 5 to 10, that'll be 7.5. The third group would be 10.5. Sorry, 10. No, 10.5, right first time. But anyway, if I highlight that and drag that down, it'll continue that pattern for me. You can see that's your minimum value for that one, and that is correct. I was talking rubbish there, yeah? That's another advantage, I suppose, of the spreadsheet. Okay, so what we've got to do now is we work out the standard deviation, step by step. So it's the last thing we're going to do now. So first of all, we've got to get the mean. Very important to get the mean. Remember, the formula, you need the mean. Okay? X bar is your mean. So this equals the frequency multiplied by minimal value. So do that. Basically, going to add all these up. Divide by how many there are. So the total, you see the little count there, is 196. So the mean is going to be that divided by 196. Okay, so that's my mean. Right, so now we can begin to work out the standard deviation. Okay, so you really need that column there. Just cut that and whack it over there. That's the mean. So, difference from the mean then. So this cell is 2.5 minus 11.9. That's the difference from the mean. So we'll repeat this now. Right, so we're now on that bit where we've got to square differences. So this cell is equal to this squared. Repeat that. However, there's 68 of those differences. So this next column, is that multiplied by 68. Again, you repeat this. Right, we've got to add those up. So this is the sum bit here. So equals sum of that. We've got to divide that by our total. I've forgotten what it is, so let me just highlight those again. It was all, oh, it's because I'm typing in a function. Just one sec. Sum was 196. So this equals that divided by 196. And then finally, from the standard deviation, we've got to do the square root of that. SQRT, square root of that, the vowels, that. There you go, bosh. Your final answer, done. Okay, and that's all you got to do on the first part of task 4, question 1. Sorry about the rush, but I'm hungry. I was waiting for me. I want my dinner. Okay, this is a very short little explanation of standard deviation for the benefit of HNC students that miss the sessions that can catch up. Okay. At the moment, it's testing whether or not this actually records and they can upload it. That's my real objective here. So, standard deviation measures dispersion. So, for example, if we have ball bearings, we want them to be with a certain tolerance. So, dispersion means like how varied are these ball bearings. Okay. Standard deviation, bit like the range measures dispersion. The highest datum took away the lowest. The problem with that though is it's affected by the outliers. You also get into quartile range that you've maybe seen before. So this is simply just a measurement of dispersion. So how it works is your individual data, you take away the mean, x bar, so you get a difference. So this difference can be positive or negative. You then square this. At some point you're going to do square root, and that kind of reverses it really. It's those differences, the negative, you square them, square root them, that kind of like cumulative effect is still there. So that's why I have a square root of square. So there are your differences squared. You then add them up, sigma, and divide by how many there are. Okay, so this is your formula. So first of all, you just write this formula down because we'll be using this formula.